Probability Worksheet Experimental and Theoretical. Number 1. Dale conducted a survey of the students in his classes to observe the distribution of eye color. The table shows the results of his survey. Your eye colors are blue, brown, green, and hazel. The number of blue is 12, the number of brown is 58, number of green is 2, and number of hazel 8. A. Find the experimental probability distribution for each eye color. What is the probability of blue? First, you need to look at how many students participated in this experiment. You have 12, 58, 2, and 8. When you add them all up, you get 80 students. So that's going to be the number that goes on the bottom of your fraction. So if 80 is on the bottom for blue, the number of blue was 12, so it would be 12 eightieths. But you can reduce this fraction to 3 20ths. There's 3 20ths probability of students having blue eyes. Now for brown, again, you would have 80 on the bottom and 58 on the top. When you reduce this fraction, you get 29 over 40. So there's 29 40ths probability of a student having brown eyes. In green, again, you have 80 at the bottom, and then you have 2 at the top. When you reduce this fraction, it is 1 over 40, and you have 1/40th probability of a student having green eyes. And finally, for hazel, 80 on the bottom again, and then 8 on the top. When you reduce 8 eightieths, you get 1/10th probability of a student having hazel eyes. Letter B. Based on the survey, what is the experimental probability that a student in Dale's class has blue or green eyes? That means that we're going to look at blue and green. So again, you add up the number of students and you get 80 on the bottom. And then when you look at blue, which is 12, and green, which is 2, your total is 14. Then that can be reduced to 7 40ths. There is 7 40ths probability of a student having blue or green eyes. Letter C. Based on the survey, what is the experimental probability that a student in Dale's class does not have green or hazel eyes? So we don't want green or hazel. Again, you add up all the students for the bottom number, and that is 80. And now we need to look at blue and brown. 12 plus 58 is 70, and 70 eightieths can be reduced to 7 eighths. There is 7 eighths of a chance of a student not having green or hazel eyes. Letter D. If the distribution of eye color in Dale's grade is similar to the distribution in his classes, about how many of the 360 students in his grade would be expected to have brown eyes? First, let's look at just in this experiment. Out of the 80 students, we're looking for just brown eyes, so that's 58. You can reduce 58 eightieths to 29 40ths. So right now we know the probability of having brown eyes just through that experiment was 29 40ths. But we want to know out of 360 students, which means we're going to multiply times 360. When you multiply those, you get that there are 261 students who really should have brown eyes if that was true for all his classes. In the next few questions, you're going to use the spinner to answer the following questions. Number 2, what is the probability of black? First, your bottom number of the fraction is going to be how many possible choices there are, which is 4. Then how many of them were black, and there was only 1, so that means that there is 1/4 probability of spinning black. Number 3, find the probability of spinning something that is not orange. Again, you look at your possible choices. There are 4, so 4 goes on the bottom. We don't want orange, so that means that we could have black, blue, or purple, and there are 3 possible choices, which means that there is 3/4 the probability of not spinning orange. Number 4, what is the probability of spinning blue or black? Again, you look at your possible choices. There are 4. Now we look at how many blue and black are on the board, and we have blue here and black here. There are 2 total. 2/4 can be reduced to 1/2, so there is 1/2 probability of spinning blue or black. Number 5, if the spinner is spun 40 times, how many times would you predict a spin of something that is not purple? So first look at what is not purple. You have 4 choices, and if we don't want purple, we could use black, blue, or orange, so there are 3 possible choices out of those 4. Now, because we want to look at 40 times, we're going to times it by 40. When you put this in your calculator, you will find that the probability is that 30 times you will spin something that is not purple. Number 6, Johnny spins the spinner 60 times. His results are below. For black, he had 17 times, blue 15 times, orange 21 times, and purple 7 times. Your question for letter A is, what is the experimental probability of a spin of orange? So first you have to find your fraction. You add up how many total spins there were, and there should be 60 because it said that he spun it 60 times. Now we want orange. Orange was 21, so you write 21 at the top. 21/60ths can be reduced to 7/20ths. That means there is a probability of 7/20ths that it would have landed on orange. Letter B, which color had an experimental probability that matched its theoretical probability? So now if you look back, we had 1/4 of a chance of it being black, 1/4 of a chance of it being blue, 1/4 of a chance of it being purple, and 1/4 of a chance of it being orange. That there is our theoretic probability, or what could happen. The experimental probability is found in the chart. So now, out of 60, you're looking for 17 out of 60 was black, 15 out of 60 was blue, 21 out of 60 was orange, and 7 out of 60 was purple. Some of these can be reduced. So 15/60ths can be reduced to 1/4. 21/60ths is reduced to 7/20ths. And when you look at 1/4 was the magic number we were looking at, the only one that actually was reduced to 1/4 was blue, 15/60ths. So the answer is the blue matched the theoretical and experimental probabilities.